Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Calculus. Topic Continuity and Differentiability. Subtopic Continuity. Exercise 5.1. When is a function f said to be continuous at a point x equal to c in its domain? f haiba function ama mahaki domain gi point c haiba point asida continuous oiba haibasi define to. A function f is said to be continuous at x equal to c in its domain if limit of f of x as x tends to c equal to f of c. Value anisi manarabadi functions f asi mahaki domain c da continuous oi, or limit of f of x as x tends to c means masibo amuk thugairabadi limit of f of x as x tends to c from left equal to limit of f of x tends to c from right equal to f of c. Haibadi left hand limit, right hand limit function value ahum si exist oiraba ahumak manarabade function asi c the continuous oi haigani. Graphically, the continuity of a function f at a point x equal to c is that there is no gap or jump or break on the graph of the function at x equal to c. Function ama mahaki domain da leiba point sida continuous oiba haibasidi function adugi graph adu da x ki value c ki corresponding point adu da tattaba chongdaba break leitaba haibani. When is a function f said to be continuous? Function continuous oiba function haibasi karino. A function f is said to be continuous if it is continuous at every point in the domain of f. Function ama continuous oiba haibasi function dugi domain pumnamakta function du continuous oirabadi function ama continuous oiba haigani. When is a function f said to be continuous in an interval ab and closed interval ab? Karigumba function f haiba ama open interval da continuous oiba haibasi karino, closed interval ab da continuous oiba haibasi na karino. Let us define. A function f is said to be continuous in open interval ab if it is continuous at every point of the interval. Interval adugi point kudimakta continuous oirabadi function da open interval adu da continuous oi haigani. A function f is said to be continuous in closed interval ab if f is continuous in open interval ab. Number 2, f is continuous at x equal to a, that is limit of f of x tends to a from right equal to f of a. And Roman number 3, f is continuous at x equal to b, that is limit of f of x tends to b from left equal to f of b. F haiba function ama close interval da continuous oiga hairabadi open interval ab adu da continuous oiba left a da from left ki continuous oiba end point b adu da su continuous oiba condition ahum si chum labadi f haiba function si close interval si da continuous oi haigani. Define discontinuity of a function at a point and a point of discontinuity. Function ama point ama da discontinuous oiba define to point of discontinuity haibasi should define to. Answer. A function f which is not continuous at a point a is said to be discontinuous at a, and a is called a point of discontinuity of f. Function f haiba ama mahaki domain da leiba a hariba point asida discontinuous oirabadi function ase a da discontinuous oiba kawi aduga a asibuna point of discontinuity of f kawi. 5. Algebra of continuous functions. Let f and g be two continuous functions at x equal to c. f amasung g haiba function ani c the continuous oiba function singni. f plus z, f minus z, f into z, and f by z are continuous at x equal to c, provided g of c does not equal to 0. Point amada continuous oiba function ani gi sum adu point adumakta continuous oi point amada continuous oiba function ani khaidoknarasu point aduda continuous oi. Continuous point amada continuous oiba function ani gi product su point aduda continuous oi. Continuous point amada continuous oiba function ani divide tawnarabasu point aduda continuous oi. Tabadabu g of c dudi does not equal to 0. 0 tadaba condition oigadabani. Number 6. Suppose f and z are real functions such that fork is defined at c. f amasung z haibasi real function singni fork asina point c asida define toba. If z is continuous at c and if f is continuous at g of c, then fork is continuous at c. Z haibasina c the continuous oiraba, f haibasina z of c the continuous oirabadi, fork as c the continuous oi. Statement theory mamane. Prove that modulus function is continuous. Modulus function c continuous oi prove to. Let us prove. Here modulus function is defined as f of x equal to modulus x. X belongs to R, or f of x can be redefined as minus x when x is less than 0, whose value is 0 when x is 0, whose value is x itself if x is greater than 0. That is a positive number. Let x equal to a be any real number. A haibasi x ki obiaba value singdugi manungdagi ama khakni real oiba value amani a haibasi. Case 1. When a is 0, a is 0 oirabadi, we have to test its continuity at a 0. For this, we have to find out limit of f of x as x tends to 0 from left equal to limit of f of x na 0 dagi pikpa hairagadi minus f of x kidi minus x injalani. Now it becomes a polynomial in x. Therefore, whose limit is obtained by replacing or putting x equal to exactly 0 minus 0, that is 0. Level limit is 0. Similarly, right hand limit at 0 is also f of x. We have to put x as x is greater than 0, which is also a polynomial whose limit is obtained by putting exactly at x equal to 0. We get 0. Also, f of 0 function value at 0 is given as 0. Left or right ahum simanare. Therefore, left hand limit at 0 equal to right hand limit at 0 equal to function value. Conclusion, thus f is continuous at x equal to 0. 0 the continuous array. Case 2. When a is less than 0, a is a negative number wherever we have to test the continuity of the modulus function at a negative real number. Left hand limit at a the level left hand limit t f of x t minus x the sindokrani x at the negative number the negative to pick to the negative or a minus x polynomial wherever x the epsilon minus a. Similarly, right hand limit to minus f hange functional value that is f of a su minus a hange. Right ahum simanare. Therefore, left hand limit at a equal to right hand limit at a equal to f of a, where a is a negative real number. This shows that f is continuous at a less than 0 at any negative real number. Case 3. When a is greater than 0, that is a is a positive real number, we have to test continuity of the function at a. Left hand limit at a is also a. Right hand limit at a is also a. Function value is also at a, where a is a positive real number. Therefore, left hand limit at a equal to right hand limit at a equal to f of a limit function value. These three are equal. This shows that f is continuous at a greater than 0. Thus, in all cases, modulus function is continuous. Number 8. Prove that modulus function is continuous at the origin. Modulus function je origin the continuous oi prove to. Answer case 1 of question 7. Mathaki question 7 ki case 1 adu paukumpiu. Number 8. Prove that modulus function is continuous at the origin. Modulus function je origin the continuous oi prove to. Answer case 1 of question 7 mathaki question 7 ki case 1 adu paukum piu. 9. Prove that the sine function that is f of x equal to sine x is continuous at every real number. Here, f of x is sine x whose domain is R. Let a be any real number. We have limit of f of x as x tends to a is limit of sine of x. f of x की value di sine x exactly chilani. X ta koi a log a sinjalabadi we get sine a. Also f of a function value so sine a orani. Limiting value sine a function value sine a. Thus limiting value at a equal to function value at a. So f of x is continuous at x equal to a the continuous order. But x equal to a is any real number. Hence f of x equal to sine x is continuous at every real number. Real number khudingmakta sine x asi continuous ore. As in picture sine graph ta koina class 11 da thengna kare sine graph asidi origin pawba periodic function oiba amuka katpa amukum thaba aduguma regular interval leba function ima ke atatpa jaga amata leite sidagi sukona dum physically khangi. Question number 10. Prove that tangent function that is tan x equal to f of x equal to tan x is continuous. F of x equal to tan x whose domain is R minus x equal to twice n plus 1 times of pi by 2 n belongs to z. Let a be any real number in the domain. Tangent tan x type of tangent function की domain दे r की odd number times of pi by 2 खाइदो खरनी odd number times of pi by 2 की multiple angle सिंसे खसी के angle सिंसे खाइदो खरगले महो तो महा की domain उइगनी a be any real number in the domain हारिबा function सी की domain दे लेबा any number अमनी a ने represent तोरिसी. We have limit of f of s as x tends to a equal to limit of tan x as x tends to a. f of x di tan x exactly ni x da a direct pisilo maram di domain de leba point ama direct pisimada tan a phangani. Also f of a functional value at a di tan a exactly or right ani se manare. Thus limiting function at a equal to functional value at a. These two are equal. So f of x is continuous at x equal to a the continuous array. But x equal to a is any real number in the domain adubu x ki value a asidi domain adugi any number amabu mahak na mahut sile. Hence f of x equal to 10x is continuous in its domain. 10x have a function se mahaki domain the continuous oigani. Mahaki domain na tansing to the dotted line the lady sing say pi by 2 की odd multiple since pi by 2 की odd multiple since the multiple since the graph से रोइना तटली. Remark: f of x equal to cos x cot x sec x cosec x trigonometric function ani proof thokare le mohoriba mari se are continuous at their domains makoi ki domain sing dadi makoi se continuous oigani. Ani subada every exponential function that is f of x equal to e to the power x is continuous. Exponential function singasidi continuous means everywhere continuous. Number 3. Every logarithmic function that is f of x equal to log x is continuous in 0 infinity. Logarithmic function cd positive real number singkata the maha ki domain leribadi domain asida continuous oigani. Number 4. Every polynomial function is continuous. Polynomial function kudumaki everywhere the continuous ni. Every rational function is continuous except at those points where the polynomial function in denominator vanishes. Rational function kudumaki everywhere the continuous ni maha ki makha ki function polynomial function adu 0 sarpa point na taba makaida. Exercise 5.1. Question number 1. Prove that the function f of x equal to 5x minus 3 is continuous at 0, at minus 3 and at 5. Let us taste. Continuity at x equal to 0. 0 the mahak continuous every yangsi. Level limit at 0 putoksi f of x ki 5x minus 3 which is polynomial in x therefore whose value is limiting value is obtained when x is replaced by exactly 0, that is minus 3. Similarly, right hand limit at 0 is also minus 3. Also f of 0 function value is 5 into 0 minus 3, that is minus 3. These three are equal, therefore left hand limit equal to right hand limit equal to function value. Thus f is continuous at x equal to 0. Similarly, we can prove that f is also continuous at minus 3 and 5. Question number 2. Examine the continuity of the function f to equal to twice x square minus 1 at x equal to 3. Continuity at 3. Limit of f of x tends to 3 from left equal to f of x twice x square minus 1. Polynomial in x oirabadi x the 3 direction jealousy value we get 17. Right hand limit at 3 is also 17. Function value at 3, that is 2 into 3 square minus 1, that is also 17. These three are equal. Hence f of x is continuous at 3. F have a function C3 the continuous already. Question number 3. Examine the following functions for continuity. F of x equal to x minus 5b. F of x is defined as 1 by x minus 5 where x does not equal to 5. And C. F of x is x square minus 25 by x plus 5 where x does not equal to minus 5. D. F of x is equal to modulus of x minus 5. Let us test one by one. Every polynomial function is continuous. I statement so f being a polynomial function is continuous. Piramiba f have a function polynomial function ni varamashina mahak as continuous function ni. Number B. F of x is a resonant function. F is a resonant function, so f is continuous provided x does not equal to 5. X na 5 na taba point sing the function continuous oi. Number C. F of x, which is also a resonant function. Therefore, f of x can be written as x minus 5 whole into x plus 5 whole divided by x minus 5. Cancelling common factor, we get x minus 5. Every polynomial function is continuous. So f being a polynomial function is continuous. F have a function C polynomial function oiraganina continuous oigani. D. F of x can be written as in these two ways. Implies f is continuous in the intervals s greater than 5 and x less than 5. Piramiba function j x na 5 tiki saubrasu continuous oirani, x na 5 tiki pick interval dasu continuous oiragani. But we are left with at x equal to 5. 5 kaktangare koina continuity test ogadaba. Left hand limit at 5 is 0. Similarly, right hand limit at 5 is also 0. Function value at 5 is also 0. Therefore, left hand limit at 5 equal to right hand limit of f at 5 equal to f of 5. Hence, f of x is continuous at x equal to 5. Thus, f of x is continuous function. 4. Prove that the function f of x equal to x to the power n is continuous at x equal to n, where n is a positive integer. Piramiba function asi n the continuous low n is positive integer ni. We have level limit of f at n is equal to x to the power n, whose limit is n to the power n. Right hand limit at n is also n to the power n. F of n is also n to the power n. Therefore, left hand limit at n equal to right hand limit at n equal to f of n. Hence, f is continuous at x equal to n. F privacy n the continuous array. 5. Is the function f defined by f of x equal to x less than or equal to 1? 5. X greater than 1 continues at 0, 1, 2. f is continuous in x less than 1 as f is a polynomial function x की value 1 पिकपम x की value no 1 की पिकपम मतंदा 1 की पिकपम मखाइदा function जे continuous ओइ मरम दी मासी polynomial function ने so f is continuous at x equal to continuous at 0 1 की पिकपम मखाइदा continuous orabadi f is continuous at 0 sumuchume again f is a constant function in x greater than 1 x no 1 dagi chawba matamda function je constant function oire so f is continuous at x equal to 2 2 haibasi 1 dagi chawba number ni 1 dagi chawba makhai da constant function orabadi constant functions are always continuous ni so f is continuous at x equal to 2 we are left with at x equal to 1 x equal to 1 khatang continuity test togada tangai re level limit at 1 is 1 right hand limit at 1 is 5 value ani se manadre limit does not exist hence f is not continuous at x equal to 1 piriba function je 1 da continuous oi de atai da di continuous oi number 6 find all points of discontinuity of f where f is defined by question number 6 f of x is twice x plus 3 x less than or equal to 2 twice x minus 3 when x is greater than 2 find all points of discontinuity heaven that is this clearly f is continuous in x satisfying x less than 2 and x greater than 2 yam line khange f habasi x ki value 2 amasung 2 dagi pikpa amasung 2 dagi chawma makhai da continuous oi habasi so we are left with 1 point x equal to 2 at which we examine for discontinuity अखोई दा हुजिक लेमोरिबा point 2 कक्तनी मफम असिदा discontinuity ओइबोइ दबा test तौसी we have limit of f of x at x equal to 2 from left is equal to twice x plus 3 whose limit is 2 into 2 plus 3 that is 7 right hand limit at 2 is also 1 they two are not equal therefore limit of f of x tends to 2 does not exist and hence f is discontinuous at x equal to 2 hence the point of discontinuity is x equal to 2 2 khaktang na mahak se point of discontinuity ore number 7 sub another question is point of discontinuity detect bani here f of x is defined is clearly f is continuous in x less than minus 3 x lying between minus 3 and 3 and x greater than 3 we are left with 2 points at x equal to minus 3 and 3 point ani khakta ngare atai singdari continuous oikre continuity at x equal to minus 3 test of 11 limit at minus 3 is x na minus 3 dagi pikpa already negative orani mahaki modulus di minus x orani polynomial oire x na minus 3 direct result value is 6 pange right hand limit at 3 is also minus 2 into minus 3 that is 6 and value ni se manare f of minus 3 so x na exactly minus 3 x na exactly minus 3 over this minus 3 over the ahan ba cases ta minus 3 ki da the minus of minus 3 plus 3 that is 6 over therefore f is continuous at x equal to minus 3 minus 3 da f se continuous over according to the point of discontinuity at x equal to 3 3 the amuk yang c level limit at 3 minus 6 right hand limit at plus 3 we get 20 they two are not equal therefore level limit does not equal to right hand limit thus f is discontinuous at x equal to 3 3 the marks is discontinuous or therefore point of discontinuity is only 3 question number 8 see the point of discontinuity detect hogadabani piramiba function si modulus se thugai da domain ani ama chongthorakre sumna clearly f is continuous in x greater than 0 and x less than 0 haibadi piriba function na says positive ama so negative real number pumnamakta continuous oi habasi am line khangle this adudi lemhoriba point is 0 kakta ngaire discontinuity at x equal to 0 0 da continuity test of c level limit at 0 we get minus 1. Right hand limit at 0, 1, which is also 1. Therefore, left hand limit does not equal to right hand limit. Implies f is discontinuous at 0. F have a set 0 the discontinuous order. Question number 9. Pyramid function assume amuk thugairasi we get minus 1 when x is less than 0, minus 1 x is greater than or equal to 0. Clearly f is continuous in x less than 0 and x greater than 0. For continuity at x equal to 0, left hand limit at 0 is minus 1. Right hand limit at 0 is also minus 1. Function value at 0 is also minus 1. Therefore, f is continuous at 0. F is 0 the continuous already. Question number 10. Clearly f is continuous in x greater than 1 and x less than 1. F hariba function asi 1 amasung 1 dagi sauba amasung 1 dagi pickle number punamakta intervention the continuous already. Then we are left with 1 point that is 1. We have to test its continuity at x equal to 1. Left hand limit at 1 is 2. Right hand limit at 1 is also 2. F of 1 is also 2. Therefore, left hand limit equal to right hand limit equal to f of 1. This shows that f is continuous at 1. F is continuous 1 the continuous already. There is no point of discontinuity. Discontinuous over point amata laitre. 1 dagi sauba makai continuous, 1 dagi pickle makai continuous, 1 dasu continuous. Discontinuous over real number amata laitre. Function sigi domain is set of real numbers nina. Question number 11. Let's see. Clearly f is continuous in x less than 2 and x greater than 2. F have a function asi 2 dagi pikpa real number amasung 2 dagi sauba real number pumnamakta continuous oi have a si yam line khangle. Continuity at x equal to 2, 2 kakta the continuous oi boy the test of c. Left hand limit at 2 is also 5. Right hand limit at 2 is also 5. F of 2 is also 5. Left hand limit equal to right hand limit equal to f of 2. Implies f is continuous at 2. Hence, there is no point of discontinuity. Discontinuous over point amata laitre. Question number 12. Clearly f is continuous in x less than 1 and x greater than 1. Continuity at x equal to 1. Left hand limit at 1 is 0. Right hand limit at 1 is also 1. Anisi manadre. Therefore, left hand limit does not equal to right hand limit at 1. This shows that f is not continuous at 1. Hence, only point of discontinuity is at x equal to 1. Function asibu discontinuous over point 1 amma kaktang lay madu 1 dani. Question number 13. Is the function defined by f of x a continuous function? Piriba function asi continuous function oibra. Clearly f is continuous in x less than 1 and x greater than 1. Continuity at x equal to 1. Left hand limit at 1 is 6. Right hand limit at 1 is minus 4. Left hand limit and right hand limit, they two are not equal. Therefore, limit of f of x tends to 1 does not exist, and hence f is not continuous at x equal to 1. 1 the continuous order. No, f is not a continuous function. F say a continuous function oibra oide f say continuous function oide. Maramdi mahaki domain ki point pumnamakta ayambeda continuous or continuous oidaba point ama hek phangmami kupta function no continuous function kaudi. Discuss the continuity of the function f where f is defined by f of x this. F is the domain of the defined theory. Clearly, f is continuous in 0, 1, 1, 3, 3, 10. Yam line intervene open intervene ahum sida function je continuous ore maram di continuous constant function oibadina. we are left with the points x की value 0 1 3 10 हारिबा point मरी सिगता ngai कोने test तौगदरिबसी continuity at 0 level limit at 0 putoksi madu right f of 0 ga sumanare level limit right and limit puto ani mafam asdi level limit puto aroi 0 na smallest x obi aba value oirabani na right and limit right and limit puto ani 0 da f of 0 ga manare value f is continuous at 0 at 1 the left right animal pangtoni level limit at 1 3 right and limit at 1 is for manadre therefore level limit does not equal to right and limit implies f is not continuous at 1 1 the continuous oidre for 3 level limit at 3 4 right and limit at 3 is 5 manadre implies f is discontinuous at 3 3 the discontinuous oidre at 10 10 the upper limit tare mahaki du tadi mahaki level limit at 10 continuity test hoge haradi 5 f of 3 manare f is continuous at 10 continuous f se 10 the continuous sorry discuss the continuity of the function f where f is defined by f of x domain ahum the defined theory f is continuous in x less than 0 x lying between 0 1 x greater than 1 we are left with only 2 points at x equal to 0 and 1 only point ani sigak tangare kone test togudrisi at x equal to 0 continuity at this point level limit at 0 is 0 right and limit at 0 is also 0 function value at 0 is also 0 ahum si manare implies f is continuous at 0 f say 0 the continuous oiri continuity at 1 1 the muk test to see left hand limit at 1 is 0 right hand limit at 1 is 4 manadri level therefore level limit does not equal to right hand limit implies f is discontinuous at 1 1 the f is discontinuous already hence f is everywhere continuous except at 1 f have say everywhere the continuous or 1 natana number 16 clearly f is continuous in x less than -1 x lying between -1 1 and x greater than 1 we are left with points x equal to -1 1 atay intervention asidi continuous way basi am line khangle hoji ko jele mohri basi -1 amasu 1 tangari test togodrisi discuss togodrisi continuity at -1 level limit at -1 is -2 right hand limit at -1 is -2 f of -1 is -2 therefore level limit equal to right limit equal to f of -1 implies f is continuous at -1 at x equal to 1 level limit at 1 is 2 right limit at 1 is 2 f of 1 is also 2 ahum se manare level limit equal to right limit equal to f of 1 implies f is continuous at 1 f is 1 the continuous already hence f is continuous everywhere piriba function je everywhere the continuous already discontinuous oba point amata ma ki domain sta leitre question number 17 find the relationship between a and b so that the function f defined by f of x is continuous at 3 a amasu b gi piriba function c 3 the continuous oi haina piram le a amasu b gi value putu haibani a amasu b gi relationship putu haiba given that f is continuous at 3 3 the continuous oi piram me left hand limit at 3 right limit at 3 f of 3 ahum si manaba tabani f of x dx plus 1 pirani adu x greater than 3 oragadi bx plus 3 pirani asum f of 3 gidi a times of 3 plus 1 pirani value evaluate torobadi asum equation ama phangle a ga b ga yawa relationship hairagadi 3 times of a minus b equal to 2 which is the required relationship question number 18 for what value of lambda is the function defined by f of x is continuous at 0 piriba function se karamba lambda gi value na 0 the continuous oigedege what about continuity at 1 1 the continuous orana lambda gi value kaya oigedege since f is continuous at 0 so level limit at 0 equal to right limit at 0 equal to f of 0 respective value pisile we get this 0 equal to 1 equal to 0 which is false masidi lali 1 ga 0 ga manai haibasidi. Thus f is discontinuous at 0 for any value of lambda. F haibasidi 0 da discontinuous oi lambda gi longning ba value lorobasu. At 1 at x equal to 1 left hand limit at 1 is 5, right hand limit at 1 is 5, f of 1 is 5. Therefore, left hand limit equal to right hand limit equal to f of 1. Ahunsi manare f is continuous for any value of lambda. Any value of lambda that f is continuous with. Question number 19. So that the function defined by z of x equal to x minus x star bracket is discontinuous at all integral points where x star bracket denotes the greatest integer less than or equal to x. Greatest integer function A, let x equal to a be an integer. Howzikti domain asidi yauba x mahaki domain di any real number ne. Adubu x dot when integer the test of hirabanina integer local a is any integer ne. We have limit of z of x at a from left is a minus of a minus 1, that is 1. Right hand limit at a is also 0. They two are not equal, thus left hand limit does not equal to right hand limit. So limit of z of x tends to a does not exist. Hence z of x is discontinuous at x equal to a. But a is an arbitrary integer. Hence z of x is discontinuous at all integral values of x. S ki integer of value khudingmakta gx as discontinuous oire. Question number 20. Is the function defined by f of x equal to x square minus sin x plus 5 continuous at x equal to pi? Piriba function ji pa x ki value pi da continuous oigadra hangmani. Yes, f of x is sum of continuous functions. As x square polynomial function ni, sin x is continuous ni, cosine function is continuous ni, sum of continuous function is again continuous ni. Yes, f of x is sum of continuous functions. Discuss the continuity of the following functions. A. F of x is sum of continuous functions. So f is continuous function. For B, f of x is difference of two continuous functions. So f is continuous function. Number C, f of x is product of two continuous functions. So f is continuous function. Question number 22. Discuss the continuity of cosine, secant, and cotangent functions. Let f of x equal to cos x. Its domain is R. Cosine function की domain दी R ni. Let x equal to a belongs to R. इमा की domain दिया होगा any number अमल lower C. We have limit of f of x tends to a is limit of cos x tends to a is cos a which is equal to f of a. Limiting value at a का function value at a का मान रहे. So f is continuous at x equal to a the continuous ओरे. Hence f is continuous function. Let g of x is cosec x. Any super function gx the kamna see its domain is R minus x equal to n pi n belongs to I. Market domain di cosecity sina already. Let x equal to a belongs to R minus x equal to n pi n belongs to I. Habiti g gi domain di yauba any number amani a asi. We have limit of gx x tends to a equal to limit of cosec x tends to a is cosec a which is value of g of a. So g is continuous at x equal to a. G is a the continuous already. Hence g is continuous function. G is a continuous function होगा. Cosecant है बस continuous function. Kataраpada secant f of x equal to sec x. Its domain is R minus x twice n plus 1 times of pi by 2 n belongs to I. Let x equal to a be in its domain. shaky domain da leba an arbitrary number amani a asi continuity at a test the limit at a putokshe shake a phange masi f of a phangste beluga manare implies f is continuous at a but x equal to a is an arbitrary value hence shake function is continuous in its domain mahaki domain na mahak se continuous hoy let f of x equal to code x see f of x the denominator see its domain is r minus x equal to n pi n belongs to I. Let x equal to a be in its domain. We have limit of f of x tends to a equal to limit of code x tends to a equal to code a equal to f of a. But x equal to a is an arbitrary number. Hence f is continuous. Question number 23. Find all points of discontinuity of f where f of x is sin x by x when x less than 0, whose value is x plus 1 when x is greater than or equal to 0. When x less than 0, f of x quotient of two continuous functions is continuous. X na negative oirabadi f of x asi continuous over function ani ki yenaba oirabadi na continuous oi. When x is greater than 0 positive the f of x being a polynomial function is continuous. X na positive the su function is continuous. We are left with one point that is x equal to 0. We have left hand limit at 0 is 1. Right hand limit at 0 is 1. Function value at 0 is 1. Therefore, left hand limit at 0 equal to right hand limit at 0 equal to f of 0. Implies f is continuous at 0. Hence, there is no points of discontinuity. Discontinuous over point amata function zigalaite. Question number 24. Determine if f defined by this is a continuous function. F to siga manarabadi continuous function oibra putu u haibani. Clearly, f of x is continuous and on x does not equal to 0. S to 0 nataba real number pumna makta function is continuous. We have to see am line khangle. We are left with 1 point at x equal to 0. We have limit of f of x tends to 0 is limit of x squared into sine of 1 by x, which is express product of two limits whose first key is 0 squared, that is 0 is the x tends to 0 with a finite number 0 into a finite number is 0 function, which is function below f of 0 with f of 0 with 0 type. Implies f of x is continuous at x equal to 0. Hence, f of x is continuous at all values of x. Question number 25. Examine the continuity of f where f is defined by this. Continuous oibo test of clearly f being difference of two continuous functions is continuous at all x does not equal to 0. F habasi x ki value 0 oidaba cases ta continuous over function ani gi difference oibanina continuous oigani. Continuity at x equal to 0. 0 the d. Let us test. Limit of f at 0 is sine 0 minus cos 0. This is minus 1, which is f of 0. Implies f is continuous at 0. Hence, f is continuous at all values of x. S की value पूर्ण मतलब function f से continuous हो रही. Question number 26. Find the values of k so that f is continuous at the indicated point in exercise 26 to 29. 26. P river function C P river point C the continuous हो रही k की value पुतो हो है बने. It is given that f of x is continuous at pi by 2. Therefore, limiting value at pi by 2 equal to f of pi by 2. Limiting value की दमकता दी f of x to asoba expression सिलावरानी function value दी 3 ओरानी. Putting pi minus twice x to theta put toro solve theta x from here we get x equal to pi by 2 minus theta by 2. Replace x by pi by 2 minus theta by 2 we get this. For this we have to put theta. For when x tends to pi by 2, x tends to pi by 2 already, x na pi by 2 the sanjala gravity theta tends to 0. The limit change to gravity tends to just change already. then this is sine or cos of 90 minus theta by 2 the sine of theta by 2 theta by 2 thamo 2 to balance from the half into torsi, that is k into whose limit is 1, whose value is half, whose value is 3, that gives k is 6, k value 6 order. Question number 27. Find the values of k so that f is continuous at the indicated point in exercise 26 to 29. 20 ka 7 chieng si to the continuous order aina piram left hand limit at 2 equal to right hand limit at 2 equal to f of 2. Left hand limit at 2 की दमकता दी kx square पिछलनी, right hand limit at 2 की दमकता दी 3 पिछलनी, f of 2 जो पिछले value. Lastly for k equal to 3 फांगे k की value dot 3 by 4 फांगे. Question number 28. It is given that f is continuous at pi. Therefore, left limit at pi equal to right limit at pi equal to f of pi. Their respective values are f of x kidi kx plus 1 sigidi pi x value na pi digi sawani cos x sigidi pi x na pi direct or gidi x na pi sinjin crow. We get polynomial in x or already sinjala. Lastly, k ki value the minus 2 by pi pang. 29. It is given that f is continuous at 5. Limit of 5 to continuous, so the left limit at 5 equal to right hand limit at 5 equal to f of 5. Limit of at 5 to the kx plus 1 lorani, sidana thrice x minus 5 lorani, 5x the exact 5 over the k into 5 plus 1. Polynomial over the direction of limiting value the lastly k value the 9 by 5 from. 30. Find the values of a and b such that the function defined by f this is continuous function. F is continuous function we get the a must b value put to. It is given that f is continuous. So f is continuous at 2 and 10. Continuity at 2 gives to the continuity wherever the left limit at 2 equal to right hand limit at 2 equal to f of 2. Function value simplification law assume na a b over equation 1 point. Continuity at 10 give left hand limit at 10 equal to right hand limit at 10 equal to f of 10. Function value pishilasi limit logshilasi, we get an equation involving a and b, that is equation 2 tole. Equation 1 amasung 2 dagi 1 kind of or a give value 2. 1 is in law a give value 2 say b give value 1 pange. Therefore a equal to 2 and b equal to 1. Question number 31. So that the function defined by f of x equal to cos of x squared is a continuous function. Let us prove. Here f of x is cos of x squared. We define z of x is x squared and I of x is cos x. Now hope of x is by definition I of z of x. Z of x is x squared. I of x squared give the cos of x squared, which is equal to f of x. But g and I are continuous function. G na continuous function obegi maram the polynomial function ni. I na continuous obegi maram the cosine functions are always continuous ni. Hoax na f of x tare. Hence f being a composite of two continuous functions is continuous. Question number 32. So that the function defined by f of x equal to modulus of cos x is a continuous function. Similarly, we can prove. We define two new functions, g of x is cos x and I of x is modulus of x. Now, hope of x is I of z of x, I of z of x the cos x lady, I of cos x the modulus of cos x, which is again equal to f of x. But g and I are continuous functions and hope is equal to f. Hence, f is continuous function. 33. Examine that sine of modulus x is a continuous function. For 33, let f of x equal to sine of modulus x. We define two new functions, z of x equal to modulus x and sine of I of x equal to sine x. Now, hope of x is I of z of x, I of z of x is modulus of x. Modulus of x, I of something is sine of something, which is again f of x. But g and I are continuous functions and hope is equal to f. Thus f is a continuous function. 33 over. 34. Find all the points of discontinuity of f defined by this. Modulus function is continuous everywhere. Modulus function singly everywhere continuously. Also difference of two continuous functions is again continuous. Continuous over function ani difference a continuous function ni. So there is no point of discontinuity. Question number 34 ki piriba function ki point of discontinuity amata leite.